Welcome to my YouTube channel, friend. Today is the numerical I am going to deliver. This numerical is nothing but the thin semicircular cylinder. Thin, this is the thickness of this semicircular cylinder of mass m. Okay, and the radius. This will be its radius r on the horizontal surface. Means this thin semicircular cylinder, when it rotates or it is given some acceleration or velocity or displacement like this, the theta is the displacement. Okay, so when it displaces from this position, so it will vibrate like this. So without slipping, what we have to find out in this numerical? We have to find out the natural frequency. So this is the given data to you, semicircular cylinder. Here in this case the mass m and r for the semicircular cylinder we know. So what we have to find out? We have to find out it's a natural frequency. So here suppose this is the dotted line. Here it will show the center of this mass of this semicircular cylinder. Here the G is the point where the center of gravity is there. If we consider here, and it will rotate about this one O. Okay, so what is the O point here? O point become a point about the mass moment of inertia of this total body which will rotate. Okay, this point, the mass moment of inertia which will rotate, that is equal to IO. That IO becomes here mr square. We can calculate by using for this weight we know and radius we know mr square. But here in this case what will happen? When it will vibrate or rotate like this, so this G point is and this point P is there, where the point of contact of this semicircular cylinder with this surface, horizontal surface is there. When it is deflected by angle theta, this theta, what will happen? It is seen that the self-weight creates movement about the point P. So what we have to find out the moment of inertia about point P. For this we require to find out the IP. This is the IP, moment of inertia about point P, where it will touch at this point. Okay, and with this couple it will form and displacement and this acceleration IP into theta double dot, that will form the restoring couple when we will rotate like this. Okay, it will try to move like this. So this displacement when we give like this, the mgx, x means this distance. Okay, so I will show you in this next diagram. So for this one, what we have done to calculate this one, mass moment of inertia at point O, we can calculate by using the mr square, and at point G, that is ICM, what we can calculate? ICM is equal to this IO minus m into h. H is what? This distance, m into h square. Okay, so this in this way we can calculate this ICM. This value of ICM we can calculate. Once by ICM we can calculate the IP also. IP at the mass moment of inertia at point P we can calculate by using this IG minus this R. Okay, this we can find out. I will show you how we can find out. So in this case, what will happen? As per Newton's second law of motion, this accelerating couple, this IP theta double dot. Okay, and in this case the external couple were applied the here displacement in this direction or in this direction. that displaced by theta. So this displacement we have to find out, this x we have to find out. This x is the displacement, okay, along this direction it is moved, okay. So this inclined direction, horizontal direction in the x, okay, that we have to find out. And this x, this value of x into this mg, okay, this weight, that is the external couple is formed around this. When we push it in this direction or pull it in this direction, the distance at a distance x, it will rotate about that center g. Similarly, ip theta double dot is equal to accelerating couple is equal to mg x. But ip theta double dot, we can rewrite this equation like this also, ip double dot plus mg h, or we can write here ip theta double dot means acceleration, mg h, we can put the value of h, how, 2r by pi. This 2r by pi means nothing but the value, this distance of g from this center of moment of inertia at this point O, okay, this 2r by pi, it is we know, okay, given is a standard formula. So what we have done here is putting the value of pH 2r by pi, we can rewrite this equation like this, theta double dot plus 2mg r, okay, divided by pi ip theta. Just comparing with the simple harmonic motion, this equation of the motion, that x double dot plus omega n ax is equal to 0, and this theta double dot plus 2mg r in denominator pi into ip, okay, into theta is equal to 0. So this will become your omega n square. This omega n square is equal to 2mg r by pi into ip. So we can write like this also, omega n is equal to under root of 2mg r by pi into ip. To calculate this value of ip here, to calculate this ip, we can consider the mass moment of inertia. What do I consider? Mass moment of inertia at point O, okay. Why it is required, I will tell you. This once we know this I is equal to this m into r square, correct. This is the mr square is equal to io. This mass moment of inertia about g means at this point, at the center point, this is the O point, okay. This is in this center of this semicircular here, half semicircular, and this is shifted somewhere here at a distance of h. So in this case, this io is mr square. Already we are mass moment of inertia about g, we can write as per the parallel axis theorem, okay, parallel axis theorem, this io is equal to what, ig plus ms square. Already we know this ig plus ms square. Ig is nothing but the ICM. Already we have written here formula. The ICM is nothing but your ig. Means at point G, the mass moment of inertia, what will the value? This one. This ig is equal to io minus ms square. The h we know, 2r by pi square into m, and this io, value of io, already we have written mr square. This solving this value of ig, once we got it here, mr square 1 minus 4 by pi square, bracket close. This is the equation 1. So friend, here what will happen? In this case, the body is not vibrating with respect to this g. This body is not vibrating. So what is the vibrating part? This is a semicircular. It is, okay, this is semicircular, and this one is the surface, and it will be at point P. Here it is rotating. So when it will rotate like this, so it will be in next position, it will be like this. Okay, this point will shift here, this P. So this is a With this point O, and somewhere here it is point G, and what will happen then, this point P, this is the P dash, suppose this will be the point O, somewhere here G, and it will rotate like this by an angle theta. So this is the case actually. So what will happen in this case, it will not vibrate along at point G. At point G it will not vibrate about at point, it vibrates about the point P. Okay, so therefore in this case the mass moment of inertia about point P, what we have to find out, about point P we have to find out. As per parallel axis theorem, this IP is equal to Ig plus ms square. Here H is this one. Here in this case value of H is this one. So this H we can find out by using this. I will show you the diagram here. This value of P into G, that we have to find out. How we can find out? This distance R. This distance R is from this one. Okay, this distance R from the center, and we know the distance, this one. This vertical distance we know, or we can say like this. Here I will show you. This is the distance R, and when this move from this position, or this is the distance R, and this distance G, PG, this is the PG, and this is the O. So what we have to find out, PG is equal to the total distance R, correct? Here what we have written is R minus this distance is, we know this distance is 2R by pi. So here 2R by pi, subtracting here this distance PG, we can calculate. Here in this case what we have to do, here the m into PG square. So IP is equal to MR inside the bracket 1 minus 4 by pi r square plus MR plus this m into R. This is the formula finalized, we have written here 1 minus 2 by pi bracket close its square. So solving this equation, IP is equal to this MR 1 minus 4 by pi square, this 1 minus 4 by pi square, plus this MR we have taken constant outside here. So what is the remaining here? This is B, its square, A minus B, its square. What is the solution for this one? A square minus twice AB minus B square. So here written A square of 1 minus twice 4 upon pi plus here plus B square. So 2 square means 4 by pi square. So what will happen if we write here 4 by pi get cancelled, and this 1 becomes 2. Okay, here is the addition, 1 becomes 2. So the answer becomes 2 minus 4 pi. So IP becomes, I am rewriting this MR into inside the bracket 2 pi minus 4 upon pi, total upon pi. This value, substituting this value IP equation 2 in this omega n. This is the omega n here in this equation. Just where to put this equation. Suppose this is equation 2. Okay, so this is equation 3. Put the IP in equation 2. Okay, so what will happen here? I have written this formula 2mgr upon pi by IP again. So putting this value of IP, this mr square 2 pi minus 4 by pi, this pi get cancelled, m get cancelled, r and 1r will get cancelled. Remaining is what? 2g upon r inside the bracket 2 pi minus 4. So this is your natural frequency, natural circular frequency. This is your frequency of oscillation. Okay, this two value, hence your answer becomes this one, the trend. So if you want few more numericals on the vibration, please write on the comments, and like, share and watch all the videos related to new videos. For subscribe my channel YouTube Kadam Academy. What are the outcomes of this video of mathematical modeling for this all the vibrating system? Write down 3 outcomes. And friend, here you always learn by self-assessment only, and you have to subscribe my channel Kadam Academy. If you are not subscribed, please subscribe it. Thank you very much.